Okay, so this is on page 92 of the notes files, and this is binomial distribution scenario number 2. And on the previous binomial distribution, we were working with 5 trials. Now we're going to increase it to 20, because with 5, we might be able to say, hey, we don't need the CDF. We can just add up all the PDFs. But when you get to 20, that's going to be very, very cumbersome. So here we go. Johnson's statistics exam has 20 true-false questions. All right, so we have a specific number of trials. Because we have a specific number of trials, that tells us we're working with the binomial. And they're true-false, so that means our probability of guessing correctly is 0.5, and the probability of guessing incorrectly is 0.5. So we have 0.5 and 0.5 as our probabilities. What's the probability that it gets no more than 14 correct? Now, I'll come back to that. No, let's do that right now. So no more. Whenever we have these problems like this, I always make my number line number 0, 1, 2, and I always go 1 above and 1 below. So dot, 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 13, 14, 15, dot, 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 all the way to 20. You notice I didn't write all the numbers down. It's not because I'm lazy. I'm just being efficient. All right, no more than 14. Means 0, 1, 2, 3, all the way up to 14 would satisfy. So in this particular case, I've circled more than one value. Because I've circled more than one value, this makes it a CDF. We happen to have 20 trials or 20 questions on the test. The probability of guessing correctly is 0.15, and my highest value circled is 14. All right? Because I'm going from left to right, I can just use a CDF, and this will be a fairly easy problem. Now, I want to point out one thing to you. Well, if he's guessing 14 right, 14 out of 20 is a 70. So we're figuring out the probability he makes a 70 or lower. That's what we're essentially figuring out real quickly. So work shown on this. We always start with the lowest, and we always go to the highest. So the lowest on this one is we have 20, choose 0. 0.5, that's the probability he guesses right to the 0 power. 0.5, 20 minus 0 is 20. Plus, dot, 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 plus. Please note this real quickly. This is the probability he got none wrong, right, and he got them all wrong. This one right here is the probability that he guessed 14 right, so 0.5 to the 14th, and then 0.5. 20 minus 14 is 6. This will be your work shown. So this is what you're showing for your work, but this is what we're using on the calculator. So here we go. Second vars, binomial, CDF, trials is 20, probability is 0.5, x value is 14. And we find out 0.9793. Now that's kind of interesting. What is that? Well, that basically says there's about a 98% chance that he makes a 70 or less if he just guesses. I'm thinking Johnson probably should study. Here it says, what's the probability he gets exactly 14 correct? Well, because we have 20 trials, this makes it a binomial. But we need exactly, which makes this a PDF. PDF, because it's a specific number. So we have 20 trials, and then we have 0.5 is the probability of guessing correctly, and we want specifically 14. Work shown for this is just going to be 20 choose 14, 0.5 to the 14th, 0.5, 20 minus 14 is 6. All right, and so when we go to the calculator, second vars, binomial PDF, 20 trials, P is 0.5, X value is 14. So the chance that he makes a 70 on the test, the chance of making a 70 on the test is 0.0369. So a little less than 4% chance that he makes a 70 on the test. What is the probability that he gets less than 10 correct? So I'm going to go to my number line. So 0, 1, 2, dot, 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 1 below, 1 above, dot, 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 all the way to 20. We have a specific number of trials, so this means it's a binomial. Less than 10 means 0 to 9. And by the way, guys, I really cannot stress how important it is to make the number line. Your scores will improve if you do that. Binomial 20.5, my x value is 9. Now this is a CDF, and I should have written that right here. This is a CDF, and it's a CDF because I have more than one value. All right, this is going to be the sum of the PDFs. This is going to be the sum of the 0, the PDF of 0, the PDF of 1, all the way to the PDF of 9. So I need to have, I need to show my lowest plus my highest. So this is going to be 20, choose 0, 0.5 to the 0, 0.5 to the 20, plus dot 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 plus 20, choose 9, 0.5 to the 9th. 20 minus 9 is 11. Second vars, binomial CDF, trials is 20, probability of success is 0.5. And we just said that our x value for the CDF is 9. So 0.4119. What is the standard deviation and mean for the number of correct answers? So whenever they talk about the mean, they're talking about the expected value, which is NP, which in this case is 20 times 0.5 equals 10. And that makes sense. If you're guessing and you only have 2 choices and you're guessing 20 times, you'd expect to get it right 10 times. Or if you were flipping a coin and you flip it 20 times, you expect to get 10 heads. So this makes sense. Now I shouldn't just write this. I should also say in the long run, or if we took multiple tests, or on average, if we did this over and over again, we would expect him to guess 10 correct responses. The standard deviation for this is the square root of NPQ, which is going to be 20 times 0.5 times 0.5, which in this case equals the square root, equals the square root of 5, which equals 2.236 answers. All right. All right, moving on to the next page because we're just continuing on with that scenario. So we're on to page 93. We're still working with Johnson's test. It's true, false. He still has 20 questions. So this is my trials. So 20 is the trials. Our probability of success is 0.5, which means the probability of failure is also 0.5. What's the probability that he gets at least 14 correct? So at least always tells us we have the 1 minus situation. So 1 minus the binom. Now I'm going to make my number line 0, 1, 2, dot, 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 1 below, 1 above, dot, 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 20. At least 14 means I want these values. All right, I want values 14 to 20. So I have multiple values, so this makes it a CDF. My number of trials is 20. The probability of success is 0.5. And we always subtract out what we don't want. We subtract out what we don't want, and we don't want 13. We don't subtract 14 out because we circled it. We want 14, all right? Work shown is the sum of the PDFs. So in this case, 20 choose 14. That's my lowest one. 0.5 to the 14th. 0.5 to the 6th. 20 minus 14 is 6. Plus dot, 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 plus. 20 choose 20. 0.5 to the 20th. 0.5 to the 0. All right. Now what is this? Well, earlier we said if you made 14 out of 20, you got a 70. So we're actually figuring the probability that he passes this test by just guessing. Again, it's a true-false test, so people think, hey, you know what? I don't even have to study. I'll pass this thing. So you have 20 choose 14, etc. And here we go on the calculator. We have 1 minus second vars binomial CDF trials is 20, probability is 0.5. Our X value is the lowest one we don't want, or the highest one we don't want. The highest one we don't want is a 13. So 0.057. So there's a less than 6% chance, or about a 6% chance, that you can guess and pass this test. So 0.0577. All right, not quite 6%. What's the probability that he gets at least 10? Well, once again, at least is going to be, and I should make my number line. My number line 0, 1, 2, dot, 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 1 below, 1 above, dot, 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 20. At least 10. This is my at least. So 1 minus the binomial CDF, and it's a CDF because I have multiple values. My trials is 20. The probability of guessing correctly is 0.5. And the highest value I don't want is 9. So this becomes my X. All right, that becomes my X value. Remember, this 1 comes from the binomial CDF of 20. So if you wanted to do the binomial CDF of 20 minus the binomial CDF of 9, it would work. So work shown, the sum of what we want. So the PDF of 10 plus the PDF 11 plus the PDF of 20. So in this case, 20 choose 10, 0.5 to the 10th, 0.5 to the 20 minus 10 is also 10, plus dot, 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 plus 20 choose 20, 0.5 to the 20th, 0.5 to the 0. We go to the calculator, and we're going to use the calculator commands. So 1 minus second vars binomial CDF 20, P is 0.5, X is 9, and we get 0.5881. Well, the good news of this is the chance that he makes a 50 or better. There's about a 58% chance that he makes a 50 or better. That's what that is. Because 10 correct would be 10 out of 20 is 50. What's the probability he gets more than 10 correct? All right. Once again, we need to read these numbers carefully because it will confuse you. So 1 above, 1 below, 9, 10, 11, dot, 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 20. More than 10 means we have to get 11 correct. All right. Again, we have his fixed number of trials, so this tells me it's a binomial CDF. All right. And we have 20 trials, probability of success is 0.5, and then we subtract out the one that we don't want, which is this, okay, which is the 10. Now, the calculator does something weird, or maybe it's not weird. It works from left to right. Notice I have the highest value circled. Because I have the highest value circled, this is essentially an at least problem. So this is going to be a 1 minus. Now, if it makes you feel better, you can do the binomial CDF of 20 because it's the highest value subtracting out the one that you don't want. So binomial CDF of 20, and I'm just going to abbreviate, binomial CDF x equal 20 minus binomial CDF x equals 9, because that one is this, binomial CDF where x equals 20 minus the binomial CDF where x equals 9. So here we go. Work shown is always the sum of the PDFs. So 20 choose 11, 0.5 to the 11th, 20 minus 11 is 9, plus dot, 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 plus 20 choose 20, 0.5 to the 20th times 0.5 to the 0. Okay. Work shown. Second vars. I'm going to do both ways. 1 minus second vars binomial CDF, 20, X value is more than 10, so I need to change this X to a 10. And I get 0.4119. All right, that was using the 1 minus. What if I'd done with a 20? Second vars, binomial, CDF, 20 trials, X value 20, enter, minus, oops, not plus, minus, second vars, binomial, CDF, X value is 9. And how come I got different values? Oh, because this is a 10. Sorry, got to read back. Second vars, binomial, CDF, the 20, because X is 20, minus second vars, binomial, CDF, X value is 10, 0.4119. So you can do the 1 minus, or if it makes you feel better, it's the highest minus the lowest. So really, the 1 minus just means the highest value minus the lowest value. What's the probability he gets 9 to 13 questions correct? So here we have 0, 1, 2, ... 9, 10, 11, 12, 13, ... 20, 9 to 13, that's here. So what this is going to be is we have multiple values, so we're going to have a binom CDF of 20.5, highest value is 13, minus binom CDF 20.5. Make sure you subtract out what you don't want, which is an 8. So this lower value, the upper value happens to be a 13. The lower value happens to be an X, I mean an 8. So here we go, showing our work. Our work is lowest to highest. So 20, choose 9, because that's our lowest PDF. 0.5 to the 9th. 20 minus 9 is 11. Plus ... plus 20, choose 13. 0.5 to the 13th. 0.5. 20 minus 13 is 7. All right, so here we go. The highest, second vars binomial CDF, which was 13 because we wanted the 13, minus the highest thing we don't want, which is the 8, second vars binomial CDF, change this to an 8, 0.6906, and then we have the last problem that we're going to do. All right. What is the problem he gets between 9 and 13? Notice gets 9 to 13, so that included between 9 and 13, which means we have 1, 2, ... 8, 9, 10, 11, 12, 13, ... to 20. Well, between 9 and 13 is 10, 11, and 12. So I'm really just interested in 10, 11, and 12. So this is going to be, for calculator purposes, the binom CDF 20.5, the highest value is 12, minus the binom CDF 20, 0.5, and the highest value I don't want is the 9. So my x's are 12 and my x's are not. X is 12 and x is 9. Once again, showing our work. Sum of the lowest all the way to sum of the highest. So 20, choose 10, 0.5 to the 10th. 20 minus 10 is 10, plus ... plus 20, choose 12, 0.5 to the 12th, 0.5 to the 8th. second vars, binomial, CDF, 12 minus second vars, binomial, CDF. This time x is 9. And we end up getting 0.4565. All right, 0.4565. All right, so that concludes our notes on the binomial distribution.